Bismillahirrahmanirrahim. Our next topic of digital electronics is Boolean algebra. We use the Boolean algebra to solve the logical values. Basically, it was founded in 1847 by the George Boole, and we use it in digital electronics to express our data. And we will prove its postulates by using the theorem. Its postulate says that the first postulate is a plus 0 is equal to a. Basically, these are the postulates which we will use and solve our digital electronics data. We will express the data in these by Boolean algebra. So the next is a plus 1 is equal to 1. A plus a says a plus a bar, which is equal to 1, and the multiplication of these are a dot 0, 0, a dot 1 is equal to a dot a is equal to a, and a dot a bar is equal to 0. We will use them further, so you will know that why these are the important. A dot b plus c is equal to a dot b plus a dot c. We can prove these postulates. This is not a difficult task. I will do one or two for you, and the further you will do it by yourself. A plus a bar b is equal to a plus b. The next postulate is a dot b and the whole prime is equal to a prime plus b prime, and a plus b whole prime is equal to a prime dot b prime. These are our postulates. Okay, we can prove them as we will prove the first one. It says that a and 0, when we will add them like a plus 0, we will get the result a. Like 0 plus 0, the answer is 0. Sorry, it's a. Okay, our final result. So if we will add 1 plus 0, the answer is 1. You can see that the final result we are having is the a by doing a plus 0, the first postulate. Like this, if we do for the multiplication, we have a 0 and the answer a, which says a dot 0 equal to a. Okay, 0 1 1 0. Sorry, it's 0, it says 0. A dot 0 is equal to 0. Sorry, it's 0. So whenever we will multiply 0 0 or 1 0, sorry, 0 0 or 1 0, it will give us the final result, which is 0 0. Like this, we can prove the second postulate as well. It says a with the 1, a plus 1 and a dot 1. The results a plus 1 and a dot 1. A plus 1 will give us the 1 and a dot 1 will give us the a. Now we will prove it. We will have 0 and 1. In a, the second input is final, which is 1 1. So a plus 1 will give us 1 and 1. You can see 0 plus 1, 1 plus 1. So this is correct. The second one is a dot 1 is equal to a. 0 into 1, 0, and 1 into 1 is 1. This is also correct, that we will get the output a. In this we will get the output 1. So this is how we can prove these all postulates. Okay, these all are valid and we can prove them. Now we will see one of the examples that why we are studying the postulates in the Boolean algebra. For this we will take the one example that how can we use it, that is a plus a bar dot b. So now we will simplify it, which says can write it as A plus B. That A bar dot B is equal to B. In this we have the three gates which we are using: OR, NOT, AND. We simplify it to the only one gate, that is OR, and we simplified it by using the postulates of the Boolean algebra. We will simplify it in detail that how we converted it, okay? It will be more easy for you to understand. This is, I told you that we converted the three gates, these are 1, 2, 3 gates to only one gate, OR gate, and this is how we did it. We will solve the left hand side of it, that is A plus A bar B. We can write A as A dot 1, as we know A dot 1 is equal to A. So plus A bar B. On the last page we had studied it that we can write 1 as 1 plus B. 1 plus B was equal to the 1. You can see the postulate, and A bar B, that is A1, we will just multiply it, simple multiplication. A into 1 is equal to A, plus A into B is AB plus A bar B. Now here we are again using the postulate which says that 1 plus B is equal to 1. So A, this is here we put it 1, okay? So the next postulate we are using is A plus, simply we will take the B common, and A plus A bar, which will be A plus B. This is the postulate we use, that is A plus A bar is equal to 1. So our final answer is A plus B, and this is how we use the postulate to convert the three gates 1, 2, and the three gates to simplify our expression, and we use the only one gate. Okay, this is where we use the postulate. Now this is simply a bit difficult to use and in our expressions. So now we will study the Carnot map, K-map, which is more easy in doing the Boolean algebra. That will be our next lecture.